All right, guys, welcome back. We got that nice break. I have, I graded your last two quizzes. They're in the grade books. And I'll hand those back in the next couple of days. So we have two more units left. We have stats units. And then this will lead us until the end of the month. And then next month we'll do logs and exponential functions. Which will be a good review for if you're taking AP Calculus AB or BC. Logs and exponentials will play a large role with next year's class if you're taking AB or BC. So let me just go through the calendar here, just to see if you guys have any questions. No assessments this week. A lot of this you may have seen in previous courses, such as, so today I think a lot of it will be review, mean, median, mode, range, IQR, mean absolute deviation. And then tomorrow we'll do variance, standard deviation. Thursday, Friday, we'll do normal distribution. We'll so there's quite a bit that we need to do there. So, and then we'll have review Tuesday. We'll have a short check-in quiz on Wednesday next week. Okay. And our test will be the last week of April. So if you look, that last week of April, it's going to be EOC week. So all of the classes will be a little shorter. But the longest EOCs will be Tuesday and Friday. So those classes will be cut really short, between maybe 20 or 25 minutes. But Monday, Wednesday, Thursday, we should have a good 30, 35 minutes. So we'll take our normal test and we'll split it up into 2 days. You'll take the first part on Wednesday, and then you'll take page 2 on Thursday. Yeah.
Would those days be like half days?
Yeah, so all these days will be half days. Oh, sorry, not half days. I guess in half days in the sense that you don't have to show up until, I mean, if you don't have the EOC, you don't have to show up until 10:30 or 11:45.
Oh,
yeah, but every day is still going to go until 3:30. Yeah, it's just, it would be a late start for many of us on most days. And then I'll put up I'll send you guys the EOC schedule as well when we get closer, but it's going to be like 3, 4, 5, 6, 7, and then first and second period of the day. Any questions? All right, so I think today you'll find this to be a review. Oh, and also on the back of your calendar are summary sheet, so we can refer back to this over the course of our lessons. Okay, so there's three measures of central tendency. You've heard this before: mean, median, mode. So mean is denoted by x bar. It's just the average. So average just means that the summation x means we're going to add the sum of find the sum of all the values. Divided by however many number of terms. Right, and an easy way for us to refer to this is like test grade, right? If you're trying to find the average of your 5 test grades, you would add up all 5 of your tests and divide it by 5. Now, there's also something that is similar, and that's median. Median is the number in the middle when the data is arranged in ascending order. Right. So if there are two numbers in the middle, then we find the average of those two numbers. So for instance, if I have these numbers here, 1, 2, 4, 9, and 100, what's the median out of these five numbers? 4, that's the middle number, right? But let's say we have these numbers here, 1, 2, 4, 6, 12, and 15. So here we have an even number of terms. And how many middle numbers do we have? 2, right? So if we have two middle numbers, then we find the average of those two numbers. What's the median there? 5, yeah. Okay, so mode is the number that occurs the most frequently. So there does not have to be a mode. And there can be more than one mode. So bimodal will be 2 modes, trimodal will be 3 modes. So let's say I had 1, 1, 1, 1, 2, 2, 5, 6. What's the mode in this set of data? 1, right? 1 appears the most often. But if everything appears just once, then there is no mode. Okay, so if you have your calculators, you can have that out. If you don't, you can just follow along, or you can just borrow one of mine. So given the scores from the latest test, it says find the measures of central tendency. Don't forget to put the data in ascending order. So we don't need to have them in ascending order for mean, but we do need it to be in order for median. I'm just going to go ahead and just put them in order. Just to save you the trouble, but you just understand you're going to just put them in ascending order here. So. Oops, running out of room here. I think there should be 15 scores here. 1, 2, 3, 4. So your mean, you're just going to add up all your test rates and divide it by 15. Okay, so to find the median, there's an odd number of data, so we should have just one median that we don't have to find the average here. Right. And what's the mode? Yeah, so it's bimodal, right? We have 2. There's a 5 in terms of the number of scores that repeat itself. Okay, we're also going to use this data to help us to find the 5-number summary, which is our next topic. So 5-number summary kind of allows us to see our data kind of broken up into 5 parts here. So we have minimum, which is our smallest number. We have Q1, which is the median of the lower half. If there are 2 numbers, then we're going to find the average just like how we would find the median. Okay, median is going to divide the data into a lower half and upper half. And then Q3 is the upper quartile. It's the average of your upper half of your data. Okay. And then finally, you have the largest number, which is your max. Sorry, it got moved over to the next page, but if you can put that at the bottom of the page here, we'll put min Q1. Yeah, I didn't realize before I printed this packet that there's all these extra pages, so we'll see that in the next all the way to page 11, I think. Now, median is also called Q2. Okay, so Q2 is basically right in the middle here. So Q1, Q2, Q3. So your median is your Q2. Now, if there's only one number for your median, if your median does show up in your data, then it's not going to be part of your lower and your upper half. You're going to leave that alone. So here's my lower half. And from these numbers, I'm going to find my Q1 and my upper half. There should be 7 numbers in each of the halves. So we're going to find the median of the lower half. So what's the median of this lower half here? So 74, right? There's a 1 middle number there. If there were 2 middle numbers, we'll find the average, but there's only 1 middle number, so that's our Q1. Okay, from our upper half, we're going to find the median. That median of the upper half is called Q3. So you have your minimum, Q1, Q2, Q3, and your maximum. Okay, any questions? Okay, next page. We're going to take the data that we accumulated and we're going to put it onto a box and whisker plot. Take our 5-number summary. So this plot will display the 5-number summary. So I did one for the data that we just got from those test grades. So we'll draw a number line and scale them appropriately. Keep the minimum and maximum in mind. Place the 5 points above the number line for each segment in the 5-number summary. Connect the minimum and Q1 with a line segment, as well as Q3 to the maximum. And then we'll draw a box around Q1 to Q3. So for the previous data sets, we have 32 as our minimum. Q1 is 74. Q2 is 83. Q3 is 89. And the maximum is 100. So this is called a box and whisker plot because you have a box and you have these two lines. These represent the whiskers. So there's three shapes of a box and whisker plot. You have symmetric, where everything is lined up in the center. This is where your mean and your median will be the same. Skew left, don't look at the box, look at the whiskers, right? So whichever has the longer whisker is going to indicate which direction of your skew. Right. So here, the longer whisker is on the left, so that's why it's skew left. So what's going to happen here is that here you see most of your data here. There's an outlier here. That's the case with us right here. Most of the test grades are here, but then there's one test grade that's really dragging that average down. But the median is still going to be nice, still a decent grade, but your average is going to be dragged down because of the outlier, right? So we saw that with this one here, right? That the mean got dragged down, even though the median is higher. That 32 is dragging that average score down. So whenever you have a skew left, your mean is going to be less than your median, right? Your average is going to get dragged down by that low grade. Skew right, look at the whisker. So whichever side has a longer whisker is going to be the direction of your skew. So here skewed right. Here, most of the scores are pretty low, but then there's going to be one really high grade that's going to bump up your average. But your median is going to be pretty low, but your mean is going to be a little higher. Okay, next up, we have measures of dispersion. So we talked about measures of center, right, which is, what is the average? There's different ways to represent the middle. Measures of dispersion is going to be, doesn't really tell you how good the grades are. It just tells you how far apart the grades are, or how far apart the numbers are. Are the numbers really clumped together, or are they really spread out? So one thing that you can maybe think about is, we're going to talk about this today and tomorrow as well, that when we talk about standard deviation or mean absolute deviation, how far away from the center are most of your data? If all your numbers are clumped together near the middle, that means there's a lot of consistent numbers, right? But if the numbers are all over the place, then your spread is going to be wider. Right, so range is the difference between your maximum and your minimum values. So it's just your highest minus the lowest. So your max value minus your minimum value. Okay, tells you how far apart your lowest and highest numbers are. Interquartile range, we also represent this as IQR. This is the difference between your Q1 and your Q3. So it kind of tells you the difference between the centers, like the major portions of your data. So in this case, my Q3 is 89, my Q1 is 74. My IQR is just 89 minus 74, which is 15. Okay, so now let's talk about how to find the mean absolute deviation. It's a little bit tedious, but it's not difficult. You just have to kind of know what this is doing here. So the first thing you want to do is you want to find your mean. Okay, so your mean is going to be your average. Okay. And then you're going to look at every data compared with that average. You're going to find the difference between them, but you're only going to create the positive value. Okay. And then we're going to add up all those distances between the average and each of the values, and then divide it by the number of terms. Okay, so let me work this with you slowly so that you can get comfortable with this process. Let's use the next page, page 6, since we have a blank page to work with here. All right, X bar. Okay, we know what the mean is. We're still using the same data from before. So our mean is 79.47. All right, 79. And then we're still dealing with 15 terms. So here's a table that we can create to kind of keep track of all of our data here. So I'm going to list out all the data that we've gathered. So they don't have to be in order, or they can be in order. I'm just going to just put them down based off of example 1 here that we have. So all the numbers we gotta, yes.
Is there a difference between XI and then?
Yeah, XI just means each of the terms. So
Okay.
every term needs to be involved with the mean. Yeah. So that means first term, second term, third term. Yeah. Okay, so let me show you how this works, and then you guys can do it. So we're going to subtract these two numbers. These are my individual terms. I got a packet right there. And then we're going to subtract it. So 90 minus 79.47. And whatever number we get, we're always going to take the positive of that number. So if there's a negative that shows up, just force it positive. So 89 minus 79.47. 78 minus 79.46. So here you're going to get a negative value, but you're going to force it positive. 81 minus 79.47. Here you'll get a negative value, 68 minus 79.47, but you're just always going to choose the positive.
You almost like subtract 79.47 minus 68.
Yeah, exactly. Yeah, you know, just take the higher number, just do 79.47 minus 68, that'll give you that positive. Sure. But if you always want to do xi minus x bar, then just make sure you never put a negative here. Now, you're going to do this until you reach 15 numbers. And then what you're going to do is, we don't care about this anymore. You're just going to find the average of all these 15 numbers and divide it by 15. That will tell you, on average, how far spread out are you from 79, from your average grade of 79. Okay, does that make sense? So right now I have 1, 2, 3, 5 numbers. You're going to try to get 10 more numbers, and then you're just finding the average of these 15 numbers divided by 15. Okay, I will show the work a little bit, but how do you guys try it? So I highlighted the 15 numbers that you want to be working with, add them all together, divided by the number of terms. So on average, these scores are 9 points away from the average. So, you know, a more consistent student would have a lower mean absolute deviation. A less consistent student will have a larger mean absolute deviation. Doesn't mean that you're better or worse student. It just tells you how clumped together your grades are. Okay, let's go to page 7. Actually, let's do page 7 so then we can get some practice with the mean absolute deviation. Okay, let's just use these numbers so we can just work with the same data. Let's say is the class 8 students were asked how many number of pets they have, and these are the answers. So 2 people with only 1 pet, 3 people with 2 pets, 2 people with 3 pets, and 1 person with 7 pets. So let's just use that data to work off of for our, so see how much we can remember from what we did. Okay, so we have 1, 1, 2, 2, 2, 3, 3, and 7. I'll write them here again. So let's practice, see if we can remember our steps here. Your average, median, and mode, and create your 5-number summary as well as your box and Whisker plot, as well as finding your mean absolute deviation. This there's an even number of data. So we'll have to find the average of these two numbers to get the median. These are the same numbers, so our median is going to be 2. But then every number is going to be part of a lower half or upper half. Here we can find Q1 and Q3, which are the median of the lower half is Q1, the median of the upper half is your Q3. Because there's two middle numbers, we find the average of 1 and 2, which is 1.5. We find the same numbers here, so it'll remain 3. And then you can also create your 5-number summary. Okay, construct our box and whisker plot. So what can we say about the shape? Skew what? Skew right, yeah, look at the whisker, right? Whichever side is along the whisker, you're going to identify, you're going to say the direction of that on that side. Okay, your range is just your highest minus your lowest value. IQR, interquartile range, is just your Q3 minus your Q1. And then your mean absolute deviation, you're going to be using every data with this 2.63. So subtract 2.63 with all the values. And then the resulting values, you're going to find the average of all those numbers.
Why isn't the Q1 just 1?
Q1 is not 1 because Q1 is the average of those 4 numbers. Sorry, the average of the 2 middle numbers there. So 1 and 2, the average of 1 and 2 is 1.5. Okay, so the mean absolute deviation. I took my average, my X bar, subtracted that with every one of my terms, make sure that whatever number I get, always make sure that these are all positive numbers. I'm going to add these 8 numbers together, divide by 8. So on average, most people, number of pets are pretty consistent, right? They're all clumped together around the same number, except for that one student that has 7 pets, but everyone else is around the same. We're pretty close to each other. So the best measure of center and spread. If I have no outliers, meaning there's no number that's just completely outside of my most of where the numbers are, then your mean and mean absolute deviation will be the best measure of your spread. But if you're so if there's no outliers, then mean and mean absolute deviation is good. But if you have a lot of outliers, then the median is going to be better because it's going to kind of give you an idea where most of your data is. It's like your outlier is kind of not with the, it's like, yeah, it's a set of data that doesn't fit the rest of your the majority of your data, right? So using median interquartile range will allow the data to not get influenced too much by those outliers. So if you're doing outliers, then mean and mean absolute deviation kind of pushes that data. It is really, yeah, this is influenced by outliers, so it's best to use this when there's no outliers. But if there are outliers, meaning IQR will minimize the impact. Okay, with the last, let's see, another 5 minutes here. Can we just do the top part of page? Sorry about those missing pages here. Page 8. We can just get through number 1, and then we can do 2 and 3 together in class tomorrow. And those numbers are already in order, so that makes it easier for you too. Yeah, so let's see your lower half. If there's, if the median, if there's an odd number, then the median is not part of your lower number. Then it's even in the division. Yeah.